Go. All right, so today, by the end of the day, this is what you should have done. Your quiz 6.1. When you come up into red, that's when you're going to give me your score. If you get out of red and you haven't finished the quiz, then you finish it and come tell me. Okay? We're going to do the lesson together first, and then we're going to work on 6.1. This takes the last 3 units and put them all together. So if you sucked on the last 3 units, you need to get in here and get help. I'm going to offer extra help on tutorial on Friday and Monday, and Wednesday next week is when the retake for anybody that hasn't taken the test is going to be. Okay, so get that all scheduled and get it out. Okay, here we go. So, stoichiometry. Man, this stoichiometry is boring me stiff. Maybe it would be help if I had arms that I could read more than the first page. So what is stoichiometry? I don't know why, but for some reason that first page doesn't give me the arrows. So stoichiometry, basically, this is the canned version. This is the study of the quantitative relationships between the amounts of reactants used in the products formed by a chemical equation. Basically, how much of the reactants make how much of the products. That's what stoichiometry is all about. So it's sort of like a recipe. I'm trying to figure out how much I can make given what ingredients I have. Okay, so you put it in your own words. Stoichiometry just is basically a recipe that tells me how much reactants I need to get how many products. Okay, it's also a fancy word that you can throw around and people think you're smart. Stoichiometry. Okay? Yep. Often shortcutted as stoke. All right, so we've got that. It's how much reactants make how much products. Simple version. If I want to make so many cheese sandwiches, and I know it takes 2 pieces of bread and 1 piece of cheese, if I have 10 slices of bread and 10 slices of cheese, how many sandwiches can I make? 5. What's going to be left over? 5 slices of cheese, right. Okay, unless, of course, like me, I like to double the cheese. So if I double the cheese, then I'm going to use everything up, right? Okay, so what if I want to make 7 grilled cheese sandwiches? So I'm making 7 grilled cheese sandwiches. I need, yes? I would call the office because I don't know how he's got it set up and then ask for this. Yes, sorry. Okay, so we would be able to say, okay, I need 7 slices of cheese. That's easy. And I need twice that many pieces of bread, right? Well, we use a ratio. So for every 1 sandwich that I want to make, I need 2 pieces of bread, right? That's just the ratio we need. We think about it in our heads when we do it at home when we're making stuff. It's pretty easy. That's a simple one. Now what if we make cookies? So if we make cookies, we're going to have different amounts of all this stuff. We'll need 1 cup of flour, 4 eggs, half a cup of sugar, 1 cup of butter. That's a lot of butter, by the way. Half a cup of chocolate chips, and I can make 12 cookies. Okay? What if I want to make 24? You double it. You guys know that, right? So if I double it, I'm going to end up with 2 cups, 8 eggs, blah, 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 and I get 24 cookies, right? So what we're doing in stoichiometry, it is a lot of eggs and a lot of butter. What we're doing in stoichiometry is just the same stuff that you've been doing at home with this, except our recipe is a balanced equation. Okay? So, as we look at this, and this is what you've got written in your notes, what we're saying with this is for every 1 nitrogen molecule, I need 3 hydrogen molecules to go with that so that I can get 2 ammonia molecules. Make sense? It's like a recipe. Okay? So if you want to write that down, you can. It just helps us to know how much of each one we need. Now, while you're writing that down, if you haven't got out your calculator and your periodic table, please go get that or borrow one of mine so that you have them. You're going to need them for today. So calculator and a periodic table. Oh, I just put that one back. Do you want it back?
Thank you.
Yes. Run fast. Okay, has everybody got their calculator and the periodic table out? Because we're going to be using them. Okay, so going forward here, this is a ratio or a recipe for a chemical reaction. Okay? So here's my recipe. I need 1 nitrogen for 3 hydrogens to make 2 ammonias. Okay? Now, as I read problems in stoichiometry, I want to know what I have and what I'm trying to get to. So how many moles of H2? So underneath H2, I just put a question mark and I put moles. So I know that I'm trying to find out how many moles of H2. Then I say, okay, what do I have? To react with 2 moles of nitrogen. So underneath nitrogen, I put 2 moles. So I know that what I have. Then to do the reaction, I always do my T-chart. And I write what I have to start with. So my 2 moles of nitrogen. Set up my T-chart. I don't want to be in nitrogen anymore. I want to get to hydrogen. And since I'm in moles, and since this is a mole to mole to mole ratio, I can use those numbers. I put what I want to get rid of on the bottom. So I look in front of nitrogen, and there's a 1. I put 1 mole of nitrogen. I look in front of what I want to go to, which is the hydrogen, which has a 3 in front of it. And on the top, I put 3 moles of hydrogen. That way I can cancel out my moles of nitrogen, and I just go 2 times 3, and that is 6 moles of hydrogen. Okay, that is simple stoichiometry. So let's do another, or let's look at what happens down here. Wait. I'm just going to do it visually right here. So if I have 2 moles of nitrogen, which is what this is here, then I would need 3 times 2 times 3, which is 6, hydrogens to go with that. They didn't ask that. To make 2 ammonias. But since I had, I don't know why I've got 4 ammonias coming up. Should only be 2. Should fix that. Okay, I should only have 2 ammonias. Oh, because I've got 2. Yes. So that should be fixed. I'll fix that. Okay, so going forward, I should only have 1 and 2 here. But we started with twice as many. We're okay. Okay. They did not ask for how many we'd make. We were doing 6 moles of hydrogen. That's how many we would make 4 moles of ammonia if they had asked us that. Okay, so looking again, how many moles of nitrogen? So underneath nitrogen, I put question mark moles. You'll understand why I'm putting the moles there in just a minute, because we might be doing something different. Are needed to react with 3 moles of H2. So I've got 3 moles of H2 this time. So again, start with what you're given, 3 moles of H2. Set up my conversion chart. I want to get rid of moles of H2. So looking in front of H2, there's a 3. So I write 3 moles on the bottom. I want to get 2 moles of N2, so there's a 1 in front of N2. I cancel out my moles of H2. So 3 divided by 3 is 1. So again, looking at what I had, if I had 3 moles of H2, that means I needed 1 mole of N2 to go with it to make 2 moles of NH3. Okay, so that's visually what we were doing. Did they ask me about the NH3? No, but I could figure that out. Okay? Are we okay to move forward? All right. So here we go again. How many moles of NH3? So here we put a question mark. Moles are needed to produce, are produced when I have 2.5. Now we don't have a whole number. Now we're getting a little bit more involved. And it says I've got excess. So that basically means I don't need to worry about that. I've got as much as I need. So again, when you make ammonia, you actually have to have a catalyst. And we'll talk about catalysts later, but it's basically like a matchmaker. So it gets the nitrogen and the hydrogen to attach to each other. We'd start with our 2.5 moles of NH2. Again, we want to get our N2. We want to get rid of it. So we're looking at front of N2. There's just a 1. Because it's not written, so we put 1 mole. Now we're wanting to get to moles of NH3. There's a 2 in front of that. So I'll put 2 moles of NH3 here. Again, moles of N2 cancel. So 2.5 times 2 is 5, right? So these are pretty simple, right? Is everybody getting where I'm getting the ratio and how I'm getting these numbers? This is when I start with moles. I have to have moles in order to be able to use the equation. It's like I have to be able to read the equation. If it's in German and I speak English and I don't speak German, I need to get it translated before I can use it. So I have to be in the right language. Okay, so would you really quickly, in 30 seconds, balance that equation? Got 15 more seconds. You got it? Okay, who would like to volunteer the coefficients for me? 2, what? Okay, 2, 2, 3. So now we've got a balanced equation. Now we have our recipe. Okay, this right here is the decomposition of potassium perchlorate. This is when I did the gummy bear sacrifice. Remember that? In the hood? And that was the firework. Okay. So how many moles of oxygen? So question mark, moles, are produced by the decomposition of 6 moles of potassium chlorate. So I've got 6 moles of this. Again, start with what we have, 6 moles. We're going to get rid of the 6 moles by putting the 2 KClO3 on the bottom. And we're going to go to oxygen by putting 3 O2 on the top. Moles of potassium chlorate go out. 3 times 6 is 18, divided by 2 is 9. And we've got our answer. Okay, we got one more, I think, to do with this potassium chlorate. We okay to go forward? No? I definitely know when I'm not ready. Yes?
So how do you know how many moles go on the bottom?
You always look for whatever this is up in the equation and see what that number is right before it. Okay, so whatever I have on top is the bottom on the next one. So I'm looking for what number's in front of it in the equation. What I want to go to goes on top, and I look in the equation for it, and its coefficient comes down. Okay? All right, going forward to the next one. I just brought this equation over so we could still look at it. You have it at the top of your page. Here's the equation, or here's the problem. How many moles of KCl, so question mark, moles, are produced by the decomposition of 3 moles of KClO3? So, potassium chlorate. Start with potassium chlorate. What's going to go on the bottom? Yeah, the 2 right here, because I'm trying to get rid of this. So I'm going to put 2 moles of that on the bottom. What's going to go on the top? What am I trying to get to? This. So that's going to go on the top. Okay, those are moles. It's a mole-to-mole ratio when we're working with a balanced equation. Well, guess what? Moles cancel here, but so do the 2's. So I end up with 3 moles of KCl. So these are fairly quick and easy. This gets you the main idea of how we're going to use it. Now we're going to go a little bit more in depth, and we're going to bring in the other chapters. Okay? Moles are great, but it's really hard to measure moles in lab. Okay? So we go back to our molar mass. Remember that? Where you have to add up a carbon and 2 oxygens to get the molar mass, right? You're going to need to do that because sometimes they don't give you moles to start with. And so you have to change it into moles before you can use the equation. Okay, so you're going to be using your mole map, and I put another copy of your mole map down at the bottom. So here we end up with 44.009 grams of CO2 is equal to 1 mole of CO2. Your grams are always going to be equal to 1 mole. So when you set up a fraction in the factor label, 1 mole is going to be opposite the grams. This is where kids usually get messed up. That's why I'm really emphasizing. When you're going from grams to moles or moles to grams, it's 1 mole for how many grams? Okay? So, we're using our mole map. The mole becomes extremely important. Yes?
Can you go back?
Yes. Is it okay to go forward? Okay. So our mole map becomes very, very important. That yellow section in the center, I have to get to it before I can go from moles of one thing to moles of something new. Okay? Using an equation. So then we get this funky looking stoichiometry chart. All I did was turn the moles on the side. So I have to get to the mole. If they give me grams, I've got to go to moles. If they gave me atoms, I've got to go to moles before I can change to moles of something new. Okay? And then if they want atoms, I can go from moles to atoms, or I can go from moles to grams. Now getting out my little pretty diagrams here. So this is where your balanced equation goes. But to get rid of that and make it a little simpler, if they give me mass, I've got to change it using molar mass by mole to get to moles. Then I use the equation to go mole to mole. Once I get here, then I can go to mass again, or I can go to molecules. So I start with one of these two, go to here, go to here, go to here. Okay, so it's sort of a flow chart. That center part is going to be set up like this, a ratio, what we call a molar ratio. What I want to get rid of is going to be on the bottom, and what I want to go to is going to be on the top with the coefficient from the balanced equation. Okay? So let's try some. Would you take a minute and balance this? Actually, I'm going to give you 30 seconds. You can do it. Balance that equation real fast. Fifteen seconds. Okay, who can give me the coefficients for in front of those? Okay, go ahead.
1, 8, 6, 5.
8, 6, 5. Okay, well, we usually don't write ones because they end up having problems. You think they're an L or an I or something. So I usually don't write ones. The only way we write ones is if we have a multiple choice question, we need to tell you what the coefficient was. Okay, so we have 1.50 moles of pentane. That's what C5H12 is. And it undergoes complete combustion, so I've got enough oxygen. How many grams of oxygen do I need? So here, instead of grams, or instead of moles, we're looking for grams. We're going to start the same way. So we're going to start with what we were given. We're going to use the balanced equation. There's 1 mole of pentane that I'm going to get rid of. What I want to go to? The 8. So it goes on top. I'm going to cross out moles of pentane. But now we just go back to our mole map. How do I get from moles to grams? Well, I'm going to put 1 mole on the bottom, and then I'm going to have to add up 2 oxygens, which happens to be 31.998 grams of oxygen. Then I can cancel out my moles of oxygen. There's only 1s on the bottom, so all I have to do is times through the top, label it. Remember, we don't want any naked numbers. And we've got our answers. So quickly, take a minute, put it through your calculator. How many significant figures should we end up answering with? 3. So however many they give me to start with, 1, 2, that 0 is significant because it tells me how well I measured. So I've got 3 significant figures. Okay, who's brave? Who's got a calculator and got it done? Okay.
384.
One more time.
384.
384. Let's see if that's right. That's right. Good job. Okay, so let's do another one. We okay to go forward? Okay, so if I have 80 grams of CO2 that was produced, how many moles of oxygen was needed? So I look at that first up. If they give me grams, what do I know I have to do first? Have to change it to moles. And in order to change it to moles, since it's a compound, I've got to add up the formula mass. Right? We did that. We did CO2 already. How much was it? It's on the last page.
44.309.
Okay, so we added that up already, right? This was on the other page. So we're going to put, we don't want grams. We've got to get out of grams. So we're going to put that many grams on the bottom. What goes on top? It's just grams to moles. How am I doing this? I'm just going to put 1 mole on the top, right? That's just our mole map, going from grams on the right to mole in the center. That's before I can do anything about changing. Okay? So grams to mole, it's always 1 mole. Then I come up to my equation now that I'm in moles, and I can use this ratio, this 5 to 8 ratio. I want to get rid of CO2, so that 5 is going to go on the bottom with the CO2. I want to get to oxygen, so the 8 goes on top. Now this time I've got to be careful because I've got 2 numbers on the bottom. Remember, when you divide something on the bottom, you've got to put it in parentheses as you time across and then close parentheses, then hit your equals. So go ahead and throw that through your calculator. 80 times 8 divided by parentheses 44.009 times 5, close parentheses and enter. How many significant figures does this one have? 3. Good. Those zeros do tell me how well I measured, so they do count. Okay, somebody brave got an answer? Got an answer? Oh, darn. Anybody else got an answer? Got an answer? Okay, what is it? Okay, anybody got it? Second that? Okay, let's see what he did. Good job. All right, so going forward, let's try another one. We want to produce 2.75 moles of water. How many grams of pentane would be required? Okay, so now we got to think about it. What are we going to start with? 2.75, okay? Whatever they gave me, that's what I'm going to start with. Okay, now I'm in moles. Where do I go? What do I use first? What do I use first? Okay? Okay, since I'm in moles, I can go right to the equation, right? I can use this ratio right away. If I'm not in moles, I've got to get to moles. Just remember, that's why mole is in yellow up on my things. It means I've got to get to that central thing before I can change to another compound. So I'm already there. So what am I going to put on the bottom? H2O. So the 6 moles of H2O. What am I going to put on the top? What am I trying to get to? Giovanni? What am I trying to get to?
Mole.
Of?
Mole of grams.
Moles of what? What compound?
Oh, H2O.
We just got rid of H2O and we're trying to get to
6H12.
C5H12, okay, which is pentane. So that's where that's going to go there. And then we can cross out the moles of water, right? Okay, so now we're going to go forward. And in order to go forward, since it wants grams and we're in moles, we have to go back to our mole map and say, oh, I need to add up the mass of that, right? Because I need to find out how many grams are in 1 mole of pentane. So I'm going to add that up. I'll give you a minute to write that down. While you're writing that down, that next conversion, what's going to go on the bottom? What am I trying to get rid of? Moles. So how many moles do I put on the bottom? Whenever I'm going from grams to moles, it's always 1. Whenever I'm going from grams to moles, it's always 1. So then this number that I've added up goes on the top, right? That'll help me cross out moles of pentane. And I only have one number on the bottom, so I don't need parentheses. But if you put parentheses, it's not going to make it wrong. But if I need parentheses and I don't put them, it's going to be wrong. So I just get in the habit of divide parenthesis, put whatever in, close parenthesis. How many significant figures here? 3. So whatever I start with, and I've been very boring and done 3 each time. Okay, somebody new, give me what you got on your calculator here for this. Yes? 33.1. Do I have a second? Yes. Look at all those hands go up. Good job. Okay, so let's go forward. We are going to spend about 15 minutes in each area. We're going to rotate normal, so red will go back to blue, blue to green, green to red. In the red area is where you're going to tell me the score on your quiz, where you're going to get help. If you need help because you're totally lost, that's where you're going to get it. In the green area, I want you to work on your assignment, but I want you to work as a group to help each other. Don't just do it by your individual self. In the blue area, try to do it by yourself most of the time. Work on your quiz, and if you need help, you can go for either side of you for a buddy. Okay? Green area, also try and get your quiz done really quickly so when you come in the red, we can work. So red area, if you don't want to do your quiz right now, it's okay. You can come back and tell me the score so I can come around and help you with the written part right now. Okay? I'm going to put a timer up.